Hi everyone, and welcome back to another one of our instructional build videos. On today's build video, we are going to show you how to wire up your Lead Machine 1010. This is going to be all inclusive. We're going to show you how to wire up your micro limit switches, your LED light ring, also going to show you how to assemble your drag chain for the X-axis, Y-axis, and we're also going to show you how to assemble your open case. And along with that, by the end of this video, you are going to be running your machine, running code through our OpenBuilds Control Machine Driver. It's going to be super exciting to see your machine alive. So let's go ahead and go over some of these highlight points of the kit now. So the first element of this kit is going to include your LED light ring. As you can see, this is going to illuminate your whole workspace. It's a really nice addition for any type of projects at any time of the day. So the next two elements included in the kit, we're going to have our X-axis drag chain along with our Y-axis and our micro limit switches, which we will configure into a homing sequence for this build. But as you can see, utilizing the modular system of OpenBuilds, we're utilizing the single L bracket T-nut mounting configuration to give you this nice sleek look. It's low profile, really cool option for your electronics and wire management. The micro limit switches, of course, everything that you see here along with the spade connectors will be included in the kit as well. So it's a really nice addition to be able to home your machine after you're done working on your cool projects. And last but certainly not least, we have our OpenBuilds open case, which holds your controller in a nice mounting configuration and also holds all of your wires back to one unit. As you can see, we also have our fan circulating cool air onto the controller. This is just an awesome design and a really convenient way to contain all of your electronics as well as your controller board. A really nice addition to this kit. So now that we have all the highlights pointed out included in this kit, without further ado, let's go ahead and get started. Okay, for this first step, we're going to be assembling our 4-conductor wire to our female connectors, and then we are going to attach those to our male connectors attached to our motors. So first we need to gather these parts. We're going to need 4 sets of 4-conductor wire. In addition to that, we'll have 4 female connectors and a flathead screwdriver. Now with this kit, you do receive 4 male connectors, so if you're using motors other than ours, they come with the male connectors already attached. For your convenience, you can just strip down these wires and attach them to the male connectors. And this is part of the electronics ecosystem that we've developed for a plug-and-play type of connection system. So if you were to have different motors, I want to show you how to find your coil pairs. So I'm going to take this off real quick. So the coil pairs for these motors are going to be red, blue, green, and yellow. So to make sure that these coil pairs do work, and if you have different motors, you would need to test this. So since these two are coil pairs, if I connect the wires together and I move my flexible coupling, you'll hear that grind, and that's resistance in the motor. So that's how you find your coil pairs. So if I come back here to green and yellow, same thing, that grind. Now if the pairs aren't a coil, so for instance blue and green, you're not going to have any grind, no resistance in the motor. So that's how you find your coil pairs. So if you're not using these motors, just go ahead and locate the coil pairs and then attach them to the male connector in the order you see fit. So I'm going to go ahead and stick this male pin back onto my coil pairs and we will proceed. Okay, so moving back to our 4-conductor wires here with our female connectors, the first thing we're going to do is loosen each one of these screws. So you'll see a metal insert inside the female connector. If you were to stick the wire in there, which it will fit into the connector, and if you don't tighten it down properly, the wire is just going to fall right back out. So what we want to do is go ahead and loosen these preemptive so they can fully accept the wire. So you can see as I loosen this pin here, that connector is going to come all the way down. So that's exactly what you want for all of your connectors. So starting here with the 3-foot wire, I'm going to connect this one first. You can also see these wires come pre-10 for your convenience, which really helps. You don't have to twist the wires together to keep them uniform. Since they're 10, they're going to stay together, and it really makes for an easy assembly. So now what we want to do is go ahead and match up our female connector with our male. So on these motors, remember I said the coil pairs are red, blue, green, and yellow? So working right from left on the female connector, you're going to line all these colors up. So every color needs to correspond to your female connector. So we're going to get red, blue, green, and yellow. So starting with red and blue first, I'm going to attach those and then tighten down these screws. So next, green and yellow. And once those are connected, tighten down the screws. What I like to do is give these a tug, make sure that they're all fully inserted into the connector, and that looks good. So this is one of our 3-foot wires. It's going to connect to our y-axis. If you're facing the back of the machine, it'll be to the left side. And it really doesn't matter. You have a 3-foot wire for each motor on the back end of the machine, so for our y-axis and our a-axis. So just make sure that you have the 3-foot wires to the back of the machine. So now we're going to follow the same process for our additional connectors and our wires, and I'll identify each axis that these wires will connect to. So let's go ahead and get that done. So this next 3-foot wire is going to connect to our A-axis, which will be towards the right of the machine if you're facing the back. And just to show you again, as you can see, all of my wires correspond. Now if they don't, you need to reevaluate the way that you're connecting these wires into your female connector. This is very important to relay this to the controller in the proper order. So that looks good. Let's move forward. So this is our 13-foot wire. This will connect to our Z-axis. So this motor right up top here will be our Z-axis. So let's go ahead and connect that. And last we have our 7-foot wire, which will connect to our X-axis, which will be on the left side of the machine if you're facing the back. And let's go ahead and connect this to our X-axis. So now that we have our wires connected to our motors, let's go ahead and move on to the next step. On this next step, we are going to be assembling our LED light ring to our router spindle mount. We are also going to be assembling our micro limit switches. So we need to gather all these parts here. We need our LED light ring, 3 micro limit switch kits, 4 sets of our 2-conductor wire. Our tooling for this step, we're going to use our wire strippers with a clamping end, our M5 and M3 ball driver. So to get started here, first I want to start on the router spindle mount. As you can see, I've detached it from our Z-axis, and from the mechanical portion of the build, you can see where I've marked each end for the mounting of the router spindle mount. So once taking the router spindle mount off, I'm going to rotate it to the back. I'm going to take off both of these black angle corner connectors. From there, let's go ahead and take the LED light ring and mount it onto the router spindle mount. So these 2 outer holes are what we're going to go ahead and mount to. So let's take the black angle corner connectors and mount those into place. So once we have this mounted, we're simply going to attach it back to the Z-axis. So I'm going to align my drop-in T-nuts to each one of these outer tracks of the C-beam and line it up with my marked ends, which is about 2 inches from the C-beam end mount. Okay, once we have our router spindle mount attached, we're going to move to our micro limit switches. So as you can see, I have two already assembled, just to give you an idea of how these go together. So the micro limit switch attached to the plate with the M3 self tappers. I've ran my 8mm screw through the plate, adding my slot washer and drop-in T-nut. These two are in a horizontal configuration, since they are laying horizontally onto the plate. Our last micro limit switch we are going to configure into a vertical configuration. So these are the parts that are included in your kit. So taking the micro limit switch and the micro limit switch plate, we're going to mount the micro limit switch onto the plate like so, making sure that these marked sections of the micro limit switch are visible. These stand for common, normally open, and normally closed. We are going to be using the common and normally open configuration for this homing cycle, so make sure that these are facing you. So once mounted to the plate, take your M3 self tappers and attach it to the micro limit switch from the back. Once you have the micro limit switch mounted, let's take our 8mm screw, run it through the front face of the plate. From there, add the slot washer, making sure that the flat portion of the slot washer is facing away from you, and then thread on the drop-in T-nut. And that is the assembly for the micro limit switch. So from there, we're going to move to our 2-conductor wire, making sure that all of our spade connectors are connected properly to the 2-conductor wire. So what I like to do is fold the wire in half to give it some bulk, just like so. Take one of your spade connectors, slide it into place. Once you see the wire protruding through, take your wire strippers. We're going to clamp down onto this connector. Okay, since this was a 7-foot 2-conductor wire, this will be connecting to our Y-axis micro limit switch. So paying attention to the color of the wire, here on the 2-conductor wire, we have red and black. Black for negative, red for positive. Now the way that that's going to relate to the micro limit switch is black is our common ground. So I'm going to connect black to the common and red to the normally open. Just like so. So from there, I'm going to take my micro limit switch over to the right side of the machine and place it into the bottom track of the C-beam here. And this will be for our homing sequence. So once our Y-axis moves forward, it'll activate the micro limit switch and stop for the homing cycle. So I'm going to take this wire and throw it towards the back. And don't worry about the mess back there right now, guys, because we will label all of our wires and organize the mess back there. So don't concern yourself with the mess right now. Okay, moving forward. So the only 2-conductor wire that we are not going to attach the spade connectors to is our 18-foot wire. This will be for our LED light ring. So I'm going to put this to the side for now and move on to our two 13-foot wires. And similar to the same way we configured our Y-axis micro limit switch, we're going to do the same thing with our additional wire. So let's go ahead and add the spade connectors. Give those a tug, make sure that they're not coming loose. So these wires are both 13 feet, so it doesn't matter which one you connect to which micro limit switch. One's going to be vertically configured and the other is going to be horizontally configured. So taking the black to our common ground and red to the normally open. Now the vertically configured micro limit switch we are going to attach to our Z-axis. And this is going to interact with our nylon hex nut on the end of the wheel and will activate when it comes to an upright position. So I'm going to mount it here on the first track of the C-beam. And then to test this, I'm going to move the flexible coupling. So as you can see, when I come to the upright position, my micro limit switch activates, and when I come back down, micro limit switch releases. So that's exactly what we want. So moving to our X-axis micro limit switch, let's go ahead and attach our spade connectors and attach it to our micro limit switch. So once again, black to the common, red to the normally open. So once you have that configured, I'm going to take this microlimit switch and place it on the back track of the C-beam, so on this front panel before you reach the C channel. And what I'm going to do is align it with my Y-axis plate. Since the travel is maxed out to this extent, I want to line my microlimit switch up to this point so I don't minimize my travel for the X-axis. So that looks good. Now when my X carriage comes to the front position for the homing sequence, it'll activate on my microlimit switch, and that will complete the homing cycle. So moving forward to our LED light ring, so we'll take our 18-foot wire and connect it to our LED light ring. So this connector here is attached to our LED light ring. There's indicators on the bottom for positive and negative. I'm going to show you here. So the right side is going to be positive, the left is going to be negative. So loosening these pins with a flathead screwdriver, we'll insert both of these wires. Positive on the right, negative on the left. Give those a tug, make sure that they're inserted properly. That looks good. So all these wires, so again I'm going to throw it towards the back. And on our next step, we will label each one of these wires. So don't concern yourself with the mess. We're about to organize it shortly. So now that that's assembled, we have our microlimit switches and our LED light ring attached to our machine. Let's go ahead and move on to the next step. So on this next step, we're going to label all of our wires, make sure everything is organized. So let's go ahead and grab some blue painter's tape and a permanent marker. And what we would like to do here is simply locate each wire from the point of origin. So you need to make sure that you label these wires correctly, because all of these wires will relay back to our controller, and if you have something wired wrong, you're going to have some problems. So make sure that you do this correctly. We're going to go over each wire as we label it. So let's go ahead and get started. First, for our Z-axis motor wire, which is located here, I'm going to locate the end of this wire. And what I like to do is take a piece of painter's tape, wrap it around the wire completely. And the reason I do this is once we feed it through the drag chain and you have like a flag, if you were to tape it like that, it's easier to write on, but it will tear on the drag chain. So at that point, you're not going to know which wire is which. So it's best just to go ahead and wrap it around the wire completely, just like so. I'm going to label this one Z, and that will stand for my Z motor wire. You can always tell it's a motor because it's 4-conductor wire. Everything else is going to be 2-conductor, our LED light ring and microlimit switches. So let's move forward. Coming over here to my X-axis motor, I'm going to locate that. Once again, taking another piece of painter's tape, and I'm going to label this one X, and that will signify my X motor. Moving to the Y-axis motor, which will be on the left side of the machine if you were to face the back. Same thing, we'll label this one Y. Moving to the A-axis motor, which would be on the right side of the machine if you were to face the back, I'm going to label this one A. Okay, moving forward. So for the LED light ring, make sure you locate, since the microlimit switch and the LED light ring are in the same position, make sure you grab the right one. So this is the LED, so I'm going to label it LED. Next, I'm going to grab the Z-axis microlimit switch. Make sure you find it from the point of origin. And I'm going to label this one ZM for Z micro. Next, I'm going to move to my X microlimit switch, and I'm going to label this one XM. Moving forward to our Y-axis microlimit switch, which as you can see is on the left side of the machine if you were to face the back. I'm going to label this one YM. So once you have all of your wires labeled, let's go ahead and move on to the next step. So on this next step, we are going to assemble our X-axis drag chain. So let's go ahead and gather these parts. We'll need our 1000mm drag chain for our X-axis, single L bracket, 2 M3 T-nuts, 2 M3 8mm screws, 1 M5 T-nut, 1 M5 15mm screw, our 1000mm slot cover, which I've cut down to 940mm. So you're going to take 60mm off of the end of the slot cover in order to fit into our cable tray. So we need space on both ends of the 20x20, so that's the reason we're going to cut this down. In addition to that, our tooling will have our M5, M3 ball driver, and a power drill. So to get started here, first I want to come over here to the left side of the machine if you were to face the back, and we have an end cap here that we're going to take off to insert our M3 T-nut. So let's go ahead and start there, simply taking this self-tapping screw out. So the first thing we want to do is go ahead and grab the slot cover after you cut it down to 940mm, and we're going to insert it into the track of the 20x20 by sliding it through. And this is the easiest way I've found to mount this into the 20x20. So simply slide this all the way down. Once you have that complete, grab one of your M3 T-nuts and slide it into the track. And this is where our drag chain is going to mount on the bottom end. So make sure you place it to where you can access it. From there, we're going to go ahead and put our cap back onto the 20x20. Moving forward to our drag chain, first we want to mount this single L bracket to this top hole in between both of our wheels on the extra large plate, making sure that the spacing that's closest to the edge is going to mount to this hole. So the outer spacing here on this hole is going to mount to our drag chain. So take the 15mm screw, place it into the hole here, and taking the M5 T-nut, I'm going to tie this into place. So now that I have the single L bracket into place, now I want to focus on the micro limit switch, making sure that this wire runs underneath our slot cover. Let's go ahead and trace it back to the end here. We're simply going to run this underneath the slot cover, feed it through until we see it come through on the other end. So once you see it here on the other end, take my ball driver, I'm going to pull this out. Alright, and just pull it out to where you have, a couple inches. This is going to feed underneath our drag chain, so we want to make sure we don't pull all the slack through yet, because it just makes it more difficult to run it through the drag chain. So taking notice of the drag chain, you can see that the orientation of my end caps are mirroring each other, which is what we want, but I actually need to adjust this. We want the drag chain to lay on the cable tray to where this will mount to the M3 T-nut, and then the other end is going to mount underneath our single L bracket. So we need to change the direction that these are facing. So I'm going to pop this loose and make that adjustment to both ends of the drag chain. So this is exactly what you should see. So if you need to make that adjustment, go ahead and do so. So now that we have the orientation of the drag chain matched, now we need to go ahead and feed our wires through the drag chain. So locating the Z-axis wire, the LED light ring wire, and our Z micro limit switch wire, we're going to take all those wires and find the ends, because these are going to run through our drag chain. So all of these wires together, what I like to do is go ahead and tape it with some painter's tape or masking tape, and it really helps when trying to feed these wires through the drag chain. So just like so, and from the top portion of the drag chain, I'm going to feed this through until it reaches the bottom. So once you have the majority of the slack pulled through the drag chain, what I like to do is leave some slack on the top portion so it's easier to mount to our single L bracket, as well as leaving us room to configure this how we want to as far as organizing these wires. So on the next couple of steps, once we start organizing the wires, we'll use slot covers here in the C-beam track in order to keep these wires into place, as well as zip ties, just to make everything look aesthetic. So leave the little slack there, And on the opposite end of the drag chain, we're going to take the X-axis micro limit switch and run it through this bottom opening of the drag chain, and then we're going to pull that slack through. Alright, so once we have the slack pulled through, we're going to position our M3 T-nut to the bottom of our drag chain, and we're going to mount on the center hole of the drag chain. So taking one of the M3 8mm screws, we're going to mount that into place. Alright, so now that that's mounted, moving back here to the top portion of the drag chain, I'm going to mount this underneath the single L bracket. So I'm going to run my 8mm screw underneath the center hole and tie it in with an M3 T-nut on top. Alright, so now that we have our drag chain mounted, everything is looking good so far. It's really coming along nicely. So let's go ahead and move on to the next step. Okay, on this next step, we are going to assemble our Y-axis drag chain to our Y-axis. So the parts that we're going to need for this step consists of our Y-axis drag chain at 1000mm, our 1000mm slot cover, which I've cut down once again to 940mm. So 60mm is what you need to take off of that slot cover. In addition to that, we'll have a double L bracket, single L bracket, 2 8mm screws, 2 drop-in T-nuts, 2 M3 T-nuts, 2 M3 8mm screws, 1 20mm aluminum spacer, 1 M5 30mm screw. Our tooling for this step will use our M5 M3 ball driver along with our power drill. So to get started on this step, first we're going to come to the back of the machine. So as you can see, my machine is rotated 90 degrees so I can access my additional wires from the X-axis drag chain. So where your motor is attached is where the Y-axis drag chain will lay. So make sure that you do have your orientation correct on your machine. Coming towards the back here, we're going to utilize this bottom section of the 20x40 to mount our single L bracket. So taking a single L bracket, my M5 30mm screw, I'm going to place this into the spacing that's closest to the edge here, adding my 20mm aluminum spacer. I'm going to mount this into place. Now what I just did there is adjusted the orientation. I want to make sure that the system is completely straight. That's great. So let's go ahead and move on to the mounting of our double L bracket. I like to align this with my cast corners here that are holding the extrusion for our Y-axis. So aligning this into the 2 center holes of our 20x80, I'm going to mount this into place. So using both M5 8mm screws, I'm going to run these through the spacing that's closest to the edge, and I'm going to tie these drop-in T-nuts onto the screws. From there, I'm going to mount this double L bracket into place. So again, like I said, I'm going to mount it in line with both of these cast corners. Make sure that's nice and tight. Now let's move to our drag chain. So taking the Y-axis drag chain, we want to make sure that each end cap is in the right orientation. So both of these need to be changed. So popping it loose off the end. So both ends should mirror each other just like this. And I'll show you why. The top portion of the Y-axis drag chain is going to mount underneath our double L bracket. The opposite end is going to attach to the top of the single L bracket. So that being said, I'm going to take all the wires that came through the X-axis drag chain besides the Y-axis micro limit switch. We're going to leave that because that's going to tie into the bottom track here with our slot cover. So like I did the X-axis, I'm going to tape the ends of the wires here, as you can see. That way it's just easy to feed this through the Y-axis drag chain. So let's go ahead and feed this through. Once it comes through the other end, I'm going to pull that additional slack through. So once you have the slack pulled through the Y-axis drag chain, all these additional wires are going to go towards the back of the machine with both our Y-axis and A-axis, and those will all relay to our controller board. So now to mount the Y-axis drag chain, using the left hole here on the end cap of the drag chain, I'm going to mount that into place with both my M3 8mm screw and M3 T-nut. Just sliding the machine off slightly, giving me access to the bottom of the single L bracket. We want to lock this into place. Now for the opposite end, I'm going to mount it using the left hole once again, but on this front part of the double L bracket. So once again, using M3 8mm screw and our M3 T-nut, I'm going to lock this into place. So once that's mounted to our double L bracket, our Y-axis drag chain is assembled. So the last thing we need to do is go ahead and line this micro limit switch through this track of the C-beam, and we are going to cover it with our slot cover. So I'm going to run this through the track past our Y-axis plate until I reach the end here, and then I'll take the slot cover, placing it into the track. I'm going to slide this all the way down to the opposite end of the machine. And for this micro limit switch, I like to tuck the wire back underneath the plate so there's no interference with this switch when the Y-axis plate meets the switch for our homing sequence. So coming here to the other end, we'll see we have plenty of space here for our wire to come through, and back around to the back of the machine with our additional wires. So that was the assembly of our Y-axis drag chain. Machine's really starting to come together, so let's go ahead and move forward. Okay, on this next step, we're going to wire up our controller board. So on this build in particular, I'm using the X Pro controller. So that for this step, we'll just need our controller board and our flathead screwdriver. So on the X Pro controller, you'll see each axis is marked. So we have A axis here, the Z axis. So your motor wires will line up with each one of these sections, and then you have your limit switch. The only axis that will not have the limit switch is the A axis. This will be the clone to our Y, so this will run in unison with the Y axis. So all the rest of them will have the label here, so just make sure that you correspond each motor to the correct section on your controller board. What I've done here is I've just simply taken the card that comes with the controller, and I'm using that as a platform to prevent any type of debris from accumulating on the back of the controller. So the first thing I'm going to do is loosen each one of these pins. So just take the flathead screwdriver and make sure each one of these are loose so it can accept the wires. So once I have all my pins loosened, I'm going to start wiring this board up. So starting with the A-axis motor first, remember we labeled each one of our motors, so let's just find the A-axis. From there we want to correspond each one of our wires to the controller according to our coil pairs for our motors. So as you can see here on the motor, coil pairs are red, blue, green, and yellow. So that's exactly how I want to correspond this to my controller. So starting from the left, working my way to the right, I'm going to start with red and blue first. I'm going to insert these wires and then tighten these down. And you'll see that my insulation is fully inserted into this connector. It's exactly what you want. You don't want the wires hanging off the end because you might have a cross connection which could burn out a driver. So make sure that you fully insert each wire into the pin. It's very important. So next, I'll insert green and yellow. Give those a tug, make sure that they're fully inserted into the connector. That looks good. So we'll move on to the Z-axis next. And we're going to wire this the same exact way that we did our A-axis here. So starting with red and blue first. and then green and yellow. Next, we'll insert our Z-axis micro limit switch, and these wires will correspond to the board in this order: red and then black. So the symbol here to the right side is for your ground, which will be your black wire. So moving forward, just going to adjust the orientation on my board, working on the Y-axis motor. Let's go ahead and locate that wire. Once again, red, blue, green, and yellow. Next, we'll find the micro limit switch for the Y-axis, and once again, red and black to the micro limit switch input. And our last motor will be the X-axis, and once again, red, blue, green, and yellow. And our last micro limit switch for the X-axis, once again, red and black. Alright, and that's how you wire up your controller board. That's looking great. So let's go ahead and move on to the next step. On this next step, we'll be assembling our open case and attaching both our controller board and our brushless fan. So you'll need to gather these parts, your open case kit, which should include 2 of your plates, 4 M3 standoffs, 4 1/8" nylon spacers, 2 slot washers, 2 M5 15mm screws, 2 3mm aluminum spacers, 8 M3 T-nuts, 12 M3 20mm screws, 4 M3 16mm screws. So taking my controller board, I'm going to run the M3 16mm screws through each one of these holes on the controller board, and then once we have all the screws through, I'm going to add the 1/8" nylon spacers. Once you have the nylon spacers attached to the screws, take one of the plates for your open case and run them in line with the inside holes on the center of the plate. From there, I'll add my M3 T-nuts to each screw. And then taking our M3 ball driver, I'm going to tighten the system into place. Once that's complete, I'm going to add 20mm screws to each corner of the plate and attach my hex standoffs to each screw. Next, using the 15mm screws, it'll place them into each one of these holes next to my hex standoffs. And this is for mounting the open case to the back of our machine on our 20x40 rail. Adding our 3mm aluminum spacers to each screw, and then our slot washers. Next, I'll add the drop-in T-nuts to each screw. Just simply threading these onto each screw. It makes for ease of assembly when trying to mount this to the back of the machine. Just like so. So moving forward to our brushless fan, we'll take our additional plate, and on these outer holes of the plate is where our fan is going to mount. So I'm going to take each screw and put them into place on each one of these holes. Resting the plate on its back, I'll add my precision shims to each screw. And then I'll stack the fan on top of each screw, add M3 T-nuts to each screw. Once the fan is mounted to the plate, our additional 4 screws will carry on into the next step. So let's go ahead and move on to the next step. On this next step, we are going to assemble our 24-volt power supply. So in this step, we need to gather these parts. We'll need 7 foot of our power cable, which will run from our power supply to the X-Pro controller, the power wire for our power supply unit, 15 zip ties, as well as our open case 4 M3 20mm screws that were carried over from our previous step. In addition to that, the tooling we'll be using are M5, M3 ball driver, flathead and Phillips screwdriver, and some snips for our zip ties. We're going to organize all of our wires. So let's go ahead and move on to the power supply unit, making sure that we can provide power to the power supply unit. You'll see your power cord. Just strip that down. You'll see 3 different colored wires: green for ground, white for neutral, black for your line. So this will correspond to your power supply unit. Here towards the right end of the power supply unit, you'll see the symbol for ground, N for neutral, L for line. We want to loosen each one of these terminals so they can accept the wire. From there, simply insert the wire into each terminal and tighten it down. So as you can see, all the wires are fully inserted into each terminal. So what I like to do is make sure that that insulation fully inserts, just to prevent any type of cross connection between the wires. So make sure that you do assemble this correctly. Green to ground, white for neutral, black for line. So let's set the power supply to the side. Moving on to the power cable. This will provide power to our X-Pro controller from the power supply unit. As you can see, we have 2 colored wires here. Red for positive, black for negative. This will relay to our controller to the blue connector here. Taking the flathead screwdriver, I want to make sure to loosen these pins before I insert the wire. From there, I'll insert the wire, make sure that your red is matched up with the positive, black is matched up with your ground. Once again, fully inserting the wires until the insulation is in the connector. Tighten the system down. Give that a tug just to make sure that this power wire is not coming loose. You do not want any of these wires cross-connecting or coming loose. It could cause a short in your board, and even worse, fry the board. So make sure that you have a full connection there. Give it a tug, make sure that they're fully inserted. That looks good. So taking one of the zip ties, you'll see these 2 holes. That's for the purpose of zip tying this power cord to the open case. So taking the zip tie, I'm going to tighten that down. And by doing this, if there's any type of pulling motion on this power cord, the zip tie will absorb most of the force. So it's just a precaution and definitely a safety feature. So once that's tightened down, just take those snips and cut off the excess. Okay, so now that we have our power cord connected to the X-Pro controller, we now need to relay this to our power supply unit. Here on the power supply unit, you'll see positives and negatives. So 3 and 3, total of 6 terminals here for the output on the power supply unit. We want to make sure to connect our positive and our negative. I like to use these 2 terminals to provide power to my X-Pro controller. So once again, red is positive, black is negative. Fully insert the wires and tighten it down. Once again, give those a tug. Make sure they're not coming loose. So that looks good. Next, we'll take our LED light ring and connect this to the power supply. Now you have this additional length for your convenience. If you would like to place your power supply on the ground, for instance, like I usually do, I like to have this additional length on the LED light ring. So when I power up my unit, my LED light ring is going to power on as well. Now there is another option as well. If you would like to keep a power supply with your machine and your controller board, you can ride these 2 wires along with your power connector to your controller board. So simply by wiring your black with your ground, your red with your positive. And you would insert those the same way we just did this wire and clamp it down and that would provide power to your LED light ring as soon as you provide power to your controller board. So that's always an option if you want to just snip down the excess. But for me personally, I like to wire this to the power supply. So coming here to the power supply unit, I'm going to connect my LED light ring into these two terminals, positive with positive, negative with negative. So I'm going to loosen each one of these screws. So tighten that down, make sure to give that wire a tug. That connection is solid. So before we start organizing all of our wires into our open case, we need to focus on the Z-axis, making sure that we have enough length of wire so we can attach our flexible tubing along with our electrical rubber clamps. So inside your kit you'll see two of these rubber clamps, two 10mm screws, your flexible tubing, and a slot cover at 250mm. What I've done with the slot cover is I've cut it down to 195mm, and this is to fit into the Z-axis right here on this front channel, and this is going to organize our wires and keep everything nice and organized and aesthetic. So making sure that you have enough length here. As you can see, I have quite a bit of length, and if you don't, you can always pull it down through the drag chains, starting from the Y-axis drag chain, pulling it through, because as you can see we do have additional length of wire. So just pull it down through the Y-axis drag chain and then back through the X-axis drag chain to give yourself enough length here. And you'll see what I mean once we start attaching this flexible tubing. You really want that additional length, and it's going to organize everything back to your X-axis drag chain. So taking the flexible tubing, let's go ahead and attach it to our wires. So taking all of my wires to the point of the opening of the X-axis drag chain, I'm going to contain these with the flexible tubing. So you see this little crease in the flex tubing? That's exactly where you're going to insert the wires. So once you have the flex tubing attached to your wires here, take your cut down slot cover and insert it in the front track of the C-beam, making sure to contain both your LED light ring and your micro limit switch. So as you can see, the slot cover runs from the length of the point of origin from the wires up to the top of the 250mm C-beam. From there, run the wires back around the C-beam end mount, and let's go ahead and grab one of our rubber clamps and clamp the end of this flexible tubing. And on the right side of the C-beam end mount, you will see a threaded hole here. This is exactly where we're going to mount this with our 10mm screw. So go ahead and take one of the 10mm screws and let's mount this into place. Okay, so once you have that complete, I'm going to move down here to the bottom portion of my flexible tubing. Once again, taking another one of these rubber clamps, I'm going to wrap it around, and I'm going to mount it into my extra large plate here on the X carriage. You'll see this tapped hole here right underneath this screw. That's exactly where we're going to mount this. Once again, take the 10mm screw and let's mount this into place. Okay, so once we have that complete, it's one thing that I will say is make sure that the seamed end of the flexible tubing is facing away from the back of the machine. So you can see it's hidden, which is really nice just for the look of the machine. So that looks good. And another thing, we are going to zip tie this connector just to make sure that any type of pulling motion is not going to interfere with the connection between the motor and our controller. So let's go ahead and zip tie that next. Okay, so now that we have our flexible tubing installed, as you can see, this is really nice. It hides all of your wires, runs them back through the C-beam end mount here into the flexible tubing. That looks really sharp. So let's go ahead and continue on organizing all of our wires here. The additional length of wire that you see hanging down, this I usually bundle and I'll lay on the bottom of my controller here in the open case. If you would like to snip the excess off and wire it directly to where you mount the controller, that's completely up to you. I like to leave myself some options, so I bundle this wire together, zip tie it, and place it underneath the controller. The only thing that I will not bundle, of course, is my LED light ring wire. I don't want to bundle that into this because I would like the option of mounting my power supply down on the floor. So once I have the wires bundled together, I place it here at the bottom, and as you can see I still have plenty of room for my fan to circulate cool air onto the board, which is very important. You do not want to block the airflow to this board. So once we have that complete, taking my fan, I'm going to plug it into this input here that indicates fan on the board. So positive, which would be red, negative, which would be black for our fan. From there I'll take the other half of the open case, set it on top, and take the M3 20mm screws and mount this into place. So once we have the case attached, I'm simply going to take the case and mount it to the bottom track here of the 20x40. So taking my M5 ball driver, you'll see access holes here on the front of the plate. This is to access your screws. So what I like to do is take my power supply unit and put it towards the left side, towards my outlet, making sure that this case is sturdy and it is mounted. That looks good. So moving forward, we'll grab our additional zip ties and start tidying up. So what I like to do is zip tie each one of these connectors. So going through each set of 4 conductor wire, I'm going to lock this connector into place. So just like so, and then tighten that down. And I'll do this for all the connectors, just in case the machine were to move and you didn't realize that your connector was unplugged. You won't have to worry about troubleshooting your machine because these connectors aren't going anywhere. So same with the A-axis here. And for the A-axis, I like to mount the connector to the aluminum spacer. So taking the zip tie, gonna run it through and over and tighten it down. So back over to the Y-axis. Once again, I'm going to take my connector and attach it to this 40mm aluminum spacer. And for these additional wires, at the point of which they come out of the Y-axis drag chain, I'm going to zip tie those together. So again, leaving my LED light ring wire out and off to the side, I'm going to bundle these wires and zip tie them as well. The additional wire coming out of the open case, I will zip tie as well. So coming here to the X-axis, once again, I'm going to zip tie this connector. And over here on the X-axis, I'm going to zip tie this bundle of wire together. And I'm going to go on down these wires and zip tie in 3 places in total, just to keep everything nice and uniform. Taking my X-axis motor, once again I'm going to connect it to that spacer. And one last spot here at the end of the Y-axis drag chain. So last we need to go ahead and take our 500mm slot cover, and what I want to do with this is place it here on the bottom track of the 20x40 to cover this A-axis wire. So simply take this slot cover and snap it into place and we'll cover this whole wire here. Alright, so once you have that finished, Let's go ahead and move on to the next step. So on this next step, we'll be hooking up our USB cable to our controller, and also I want to show this really cool system here. It's the AC/DC relay. We use as a power strip as well as a relay for our router spindle or any tool that you would like to control from your software. It's a really cool unit, definitely an easy way to have a kill switch as well. So the way that we'll hook up the power supply is to the always on configuration onto your relay. You simply plug that in and you have a kill switch, which is a really cool option, as well as having the feature of being able to control your tooling with your software. So first, let's go ahead and connect our USB cable. So once that's connected, we'll plug this unit into the laptop. But first, I want to show you how to plug in your power supply unit. Like I said, we're utilizing the always on feature on this relay. So just taking the power cable from the power supply unit, you'll plug it into the always on. From there, you'll plug in your relay to an outlet. From there, you can power on and power off your machine. So this is a really nice unit. I would definitely suggest purchasing one. Like I said, the feature of being able to control your tooling on this relay as well, which we'll go over that in future videos. Really cool system here. So from there, you would plug in your power supply. But before we do that, we want to make sure to configure our software and make sure that all of our settings and values are inputted into our controller. So just leave that out for now. We'll plug it in once we go over the software portion of this video. So taking the end of the USB cable, let's go ahead and plug it into our laptop. And from there, let's go ahead and move on to the software portion. So the first thing we want to do is open up our browser and let's go to openbuilds.com. From there, we'll scroll to the software tab and let's download the OpenBuilds Control Machine Driver. So you have options for Windows, Mac, and Linux. I'm using Windows, so I'm going to go ahead and download this executable. So go ahead and select the download. From there, you'll see a prompt that says Windows protected your PC. We're going to select more info and run anyway. Go through the prompts and install. So let's go ahead and finish the installation. And you'll see that your driver started. Go ahead and select it. And you'll see that the shortcut is installed here to the left. So now that we're in the machine driver, we are going to select our COM port. So down here, we'll select the second option, which will be COM14, and connect to your controller. So the first thing you're going to see is the unlock alarm. Just go ahead and unlock that. It's not necessary. We haven't powered on our unit yet. So at the top of the controller, you'll see tabs for Gerbil settings and troubleshooting. We're going to select the Gerbil settings tab. And this is really convenient. Right here you see load default settings. So for each one of our machine bundles that we sell, we have all the settings preloaded into this default setting. So scrolling on down, we are going to locate the OpenBuilds Lead Machine 1010. So select that. This is really convenient because now all of our settings are inputted into our system, so we don't have to go back and forth and check on the forum for any of these settings. All these values have been calculated for you for your convenience. Of course, you can go back and tweak these if you want, but this is just a really cool feature for any machine that you buy from OpenBuilds. We got your back. So here you'll see that limit switches were installed as well, so you can toggle this off or on. Since we have micro limit switches installed on our machine, we are going to enable that. So basically what that's going to do is enable hard limits and your homing cycle. So right here you'll see the homing cycle enabled. Both hard limits and the homing cycle are enabled. Alright, so from there you'll save these settings to your firmware. And now let's go back to the control tab. From here we are going to jog the machine around. So go ahead and turn on your power supply. So once you've powered on your power supply, you should see your LED light ring illuminate your workspace. You should also hear your motors activate, as well as the fan blowing cool air onto your controller. So once you know that your machine is powered on, we are going to jog the machine around, make sure that everything is working properly. So if there's anything in the settings that we have to tweak, this would be the place to troubleshoot any of those issues. As you can see up top here, we have a troubleshooting tab, which is really convenient for testing our micro limit switches. So just to give you an example, checking the Y limit switch, you'll get an alarm that says the hard limit has been triggered, and you'll also see an indication here for the Y limit switch. So the alarm is going to activate, and this is a safety precaution, so if anything were to trip one of the micro limit switches, your machine will not move. So it's a really nice safety feature. I definitely appreciate it for any type of manufacturing. As you know, things can go wrong. And that being said, since we have our machine plugged into a power supply unit, that is our safety switch. So if we need to turn this machine off, that's exactly where we will do it. So make sure if you have any issues, you are powering down your machine. Safety first. So unlock the alarm. So we tested our micro limit switch. We know that they're activated. You can go ahead and check both X and Z. So going to the control tab, let's go ahead and jog our X axis first. I have it set on 1 millimeter increments just to make sure everything is running smoothly. So hitting a positive movement, you'll see my machine move to the right. So I know that it's moving to the right. I'm going to bump it up to 10 millimeter increments. And as you can see, this is all positive movement. Our workspace is to the left front of the machine. So that's our 0 point. So anytime you start a job, that's the position that you would zero your machine out to. So moving to the right, 10 millimeter increments, I know that the positive movements work correctly. So testing the negative, as you can see, it moves in the proper direction. So everything in the default settings is correct. We do that for your convenience. So it's definitely really easy and an awesome feature. I love it. So let's move on to the y-axis, making sure that the positives and the negatives function correctly. I'm going to jump this out 10 millimeters. As you can see, my machine is running great. So positives work great for the y-axis. Let's go to negative movements. Excellent. So everything looks good there. Let's go ahead and bump this down to 1 millimeter increments. Since our z-axis doesn't have as much travel as the x and the y, we're going to bump that down as a precaution so we don't want to ram the machine to the upright position or grind it to the bottom. So at 1 millimeter increments, I feel pretty safe. So a negative movement should be down into the material, as you can see, and positive movement should be up away from the material. So that looks great. So all of our positives and negatives are functioning correctly on this machine. It's running great, sounds great. This is really exciting. So the next step is going to be our homing cycle. So up at the top here, you'll see a tab that says Home All. Now if you have any issues with the homing sequence, if your machine starts to go in the wrong direction, make sure to turn the machine off or hit the stop job button here. Preferably just shut that machine off. We don't want it running out of control. So as you can see, the Home tab here, we'll go ahead and select that, and this will set a homing sequence. So it starts with the Z first, and then it's going to go to the X and the Y. And you'll see the homing pull off is at 5 millimeters. And then from there, you've homed your machine. That worked great. So now that we know all of our settings are correct in the machine, this is awesome. So now we have a fully functional machine. Now I want to go over some additional details here in the machine driver. So as you can see up top here, we have tooling options, which is really cool. So that AC/DC relay I was showing you, you can turn on both coolant and your motor section. So if you have a tool, you can just turn that on from your software. So of course you have to wire it to your X Pro, and we'll definitely have a video dedicated to that. But it's just a really nice feature. That relay is awesome. So you can turn it off and on. It's really convenient to be able to operate your tooling through the software. So that's a really cool feature, as well as our jog widget. So once you click the jog widget, you scan this QR code. From there, you'll be able to jog your machine from your phone. Really nice feature, really convenient, very intuitive. I really like this. It's awesome. We all use our cell phones, so we know how convenient it can be to just use your cell phone to jog your machine. It's awesome. Next, you'll see both the G-code editor, serial console, and your 3D viewer. This is one of my favorite features of the software. You can change the orientation, watch your machine work as you're manufacturing your projects. This is really cool. It's like having your CAM built into your control software. This is absolutely awesome. State of the art, very intuitive. I love it. So also you have the simulation down here. So if you want to just go ahead and check your tool paths for your projects, you would hit simulate. You can change the speed of the simulation, and of course your reset view. So just really awesome stuff here. So the G-code editor is a great place just to experience entering manual G-code. Definitely a nice feature added to the software. Alright, so now that we know that our machine is functioning correctly, let's get to the exciting part of running our first Hello World. So going back to our browser and the OpenBuild software tab, you'll see an option for our OpenBuild's CAM G-code generator. So this is an online application, so let's browse to. And what's really cool is it'll save your last workspace if you have delved into the CAM G-code generator. We are going to start with the new workspace. I want to show you guys how to set up your settings in the G-code generator. So go to the settings tab here. Right here you'll see settings options. So here's where you're going to go ahead and select your settings. So we're using the Spark Concepts X Pro, that's correct. And then here you'll see select your machine. So we're using the Lead Machine 1010. So we'll go ahead and locate the Lead Machine 1010. And now it's going to upload all the parameters for that machine. Really awesome, super convenient. So from there, you'll see options for your spindle, if you have a laser, misting, cooling. There's a couple options there for you. It's really cool. Obviously with a CNC, generally you use your spindle, especially with a machine like this, but you can use a laser as well. This is the tooling that is set as a default for this machine, so we are going to keep the spindle on. Obviously we're not going to be milling out on this video in particular, but we will have future videos of this machine in action, which is super exciting. I can't wait. So from there we'll go ahead and save these settings. And as you can see here, your workspace is populated. And once again, you can change the orientation, check your toolpaths. It's really cool. So for the workspace up here at the top, go ahead and select that. You have options to upload a DXF file, upload pictures, whatever the case is for your projects. You definitely can insert them into this CAM G-code generator. For our convenience, we have the Hello World example that we are going to start off with. So go ahead and open the Hello World example. As you can see over here, it's calculating the toolpaths for this design that we are going to use. But this is set up for our machine since we already entered our parameters, which is really cool. So now you can see your toolpaths here in the Hello World design. Like I said, you can change the orientation here. Check it out. That's really cool. Alright, so this is exciting. Let's go ahead and transfer this G-code to the machine driver. And the first thing you'll see is the design pop up into the 3D view, which is awesome. So let's go ahead and set our 0 point and start this job. So the 0 point for this machine is generally where you would set your router. So if you can envision a router where the router spindle mount is, we want to set our increments far enough away from the sides of the machine that we don't have to worry about the toolpaths interfering with our parameters. So for the x-axis, I'm going to jog this out slightly. Of course, the z-axis as well. We want to make sure to bring the z-axis down quite a bit. So this G-code is set up for an actual milling process. So if you were to set up your tooling and your bit size in the CAM software, you would be able to mill out this Hello World. For us in particular, we are going to just make sure our machine is functioning correctly and it can run this G-code. So we are doing an air cut. But that being said, since this has toolpaths and it's set up for an actual cut, we want to make sure that while the machine is rising and delving down into the material, that we do not activate the micro limit switch or grind on the top of the machine. So now for the y-axis, I'll bump that out slightly as well, and then I'll set my 0 for x, y, and z. Once you set your 0 point, let's go ahead and run this job. If you have any issues, once again, make sure to hit that power switch or stop that job. Alright, so let's go ahead and run it. So right here I'm checking my 3D viewer. You can watch your machine at work. This is really cool. This is exciting, guys. We have our machine alive. It's up and running. Now just imagine all the cool projects that you can design and mill out with this awesome machine. Okay, so now that our machine is operational, let's go ahead and install our router spindle. So what we have here is our DeWalt router. We're simply going to disassemble a couple things on the router to make it adaptable to our router spindle mount, and from there we will mount this into the position that it needs to be for material cuts. So the first thing we want to do is go ahead and home the machine. You want your machine to a homing position here. So let's go ahead and home all here on the software. Now that our machine is at the homing position, let's go ahead and move the x-axis. We want to bring our z-axis to the middle of the machine just to make it easier to install this router. So we're going to go ahead and bump this at 10mm increments. So as you can see, my machine is now accessible. Here on the z-axis, we really just want ease of assembly for our router. So what I'm going to do now is loosen these two screws on the router spindle mount. You don't want to take them out completely because we do have to tighten this back down on the router. So as you can see, you want about 1/2 inch of a gap between your top piece and the bottom U shape of your router spindle mount. So let's move on to our router. So opening the package of the DeWalt router, you will see that it comes assembled with this casing. For our machine, we are going to strip this off. So just unbuckle this latch. Right here you're going to see 2 tabs. Simply press in and slide this casing off. Now you're also going to take this coupling off, so just go ahead and spin that right off the router. And this is exactly what you should see. So as far as placement goes with the router, the collet of the router should be lined flush with your C-beam end mount. So here on the Z-axis, we are going to align our collet with the very bottom of the C-beam end mount. As far as position goes, keep your wire to the right and your adjustment button here on the router. This is to lock your collet into position so you can add bits. So we're going to keep that to the left. So just inserting the router, take a look at the position. They said you can use a ruler. What we're going to do is just go ahead and eyeball this. Try to get it as close to the C-beam end mount as possible. That looks good. So from there I'm going to go ahead and tighten down the router spindle. So what I do is I work my way from left to right, tightening down the screws at the same time. So you don't want to tighten one down completely because you're not going to get a secure mount. So just kind of work your way and feel the tension on the router. You do not want to over tighten this. So you should feel a firm lock, so if you press against that router it's not going anywhere, as well as from the top position. So that is a nice lock. As you can see, I still have room here, so we're not tightening down this top piece completely, because that will constrict your router and cause problems for the machine. So you do not want to do that. Just a nice firm lock against the router. Make sure that your collet is in line with your C-beam end mount here, and that's the installation of your router. So that completes the electronics and software assembly. Make sure to subscribe to the channel and hit that like button, and we'll see you on future build videos.